Hello everyone, this is a problem from mechanics. A chain with uniform mass per unit length lies in a vertical plane along the slope of a smooth hill. Smooth hill is there, so basically there is no friction between the chain and the hill, so it is free to slide. The two ends of the chain are at the same height. These are the two ends of the chain and they are at the same height as shown by the dotted line. If the chain is released from this position, we have to find its acceleration. So first of all, let us mark the endpoints as A and C. And the topmost point of this chain on the incline, let us call this point as B. And since it is not mentioned, let us assume that the vertical height between the topmost point B and one of the ends is H. Next, if we consider a small element of length dl of the chain lying on the incline, then due to its weight, force df will act down the incline, and df can be written as dm small mass of the small part into g into sine theta, and theta is the angle that this dl makes with the horizontal at near its position. Now dm we can write as, let us assume lambda is the linear mass density, lambda into dl, this will be dm. So if you substitute this value of dm, then we get df equal to lambda dl into g into sine theta. And if we integrate, we will get the total tangential force due to the part AB. So net gravitational force along the slope on part AB will be integration of lambda dl g sine theta. Since lambda is a constant, in fact g is also a constant, and theta will vary for different positions of dl. So we can bring out lambda and g outside, and then we will get dl sine theta integration. Now dl sine theta is nothing but the vertical component of this vertical component of this element. This is dl sine theta, and definitely integration of dl sine theta will give us h. So if we go on further and integrate it, we will get it as equal to lambda g into h. So this is the net force, and this force does not depend on the profile of the hill. It only depends on the vertical height between the points A and B. So based on this logic, we can say that the portion BC, on the portion BC also the same force will act. So basically the net force on the chain will be 0, and so we can say finally that the acceleration of the chain will be 0. So acceleration of chain will be 0. So that will be the answer to this problem. I hope it is clear to you. Thank you very much.